All right, let's talk about how the pros really deliver software. We're going to dive into orchestrating CI/CD workflows using two of the biggest tools in the game, Jenkins and GitHub Actions. Let's get right into it. But first, I have to ask, are you still running tests by hand, pushing deployments with a manual script, clicking through screen after screen just to get your code live? Come on, we all know that pain. There is a much, much better way. I mean, just look at the difference. It's like night and day. The old manual way is slow, it's risky, and let's be honest, it's just asking for a typo to bring down production. But the CI/CD approach, it's fast, it's reliable, and it's all automated. This isn't just a small improvement, it's a total game changer. So here's our mission for the next few minutes. We are going to build a self-driving delivery system for your code. A system that takes your work and automatically gets it tested, validated, and shipped, all while you're grabbing another cup of coffee. So what do we call this magical system? It's a CI/CD pipeline. And the best way to think about it is like an automated factory. Your code goes in one end like raw material, and a fully built, quality-checked, ready-to-ship product just rolls out the other end. And here's what that factory floor looks like in action. It all kicks off the second you commit your code. The pipeline snags it, builds the application, and then runs all the tests, your unit tests, API tests, the whole shebang. And only if everything passes does it deploy to the server. It's a perfect, seamless flow. Now, the two main factory managers you'll see out there are Jenkins and GitHub Actions. Jenkins is that classic self-hosted workhorse. It's perfect for really complex setups where you need total control. GitHub Actions, though, lives right inside your repo, and it's all driven by these super clean YAML files. We're going to focus on GitHub Actions today, but honestly, the core ideas apply to both. Okay, enough theory. Let's get our hands dirty and actually build your first pipeline. We're going from a fresh piece of code all the way to a live deployment. So here's the game plan. First, we'll define what kicks the whole thing off, the trigger. Then we set up our environment, run our tests, and pay attention here, this part is critical. We implement a quality gate. After that, it's all about automating the reports and finally integrating the deployment. Let's zoom in on the important bits. This right here, this is the blueprint for our entire operation. It's a GitHub Actions YAML file, and it's way simpler than it looks. See this first highlighted line? That's our trigger. It just means, hey, run this workflow anytime someone pushes code or makes a pull request. And what does it do? This second line tells it to run our API tests. That's it. You've just automated your testing. Okay, hold on. Stop everything. Before we move on, we have to talk about this. This is, without a doubt, the single biggest, most common security mistake people make. Putting your API keys or passwords directly into your script is like writing your bank password on a sticky note and putting it on your monitor for the world to see. So what's the right way to do it? You use the platform's built-in secrets vault. See this syntax? This tells GitHub, hey, go grab the production API key from your secure encrypted storage and inject it here only when the pipeline is running. It never, ever gets exposed in your code. This isn't a suggestion, it's a must-do. All right, you've got the basics down. Now let's talk about the landmines. These are the rookie mistakes that, seriously, 90% of people make when they're starting out. Let's help you skip all that pain. First up, hard coding secrets. We just hammered that one home. Don't do it. Second, forgetting about Newman. If you're using Postman for your API tests, you absolutely need its command line runner, Newman, to run those tests in an automated pipeline. And third, and this is a sneaky one, creating tests that depend on each other. If your update user test only works after your create user test runs, you've got a problem. Every single test needs to be a self-contained universe. Okay, so you know what not to do. Let's flip the script. Let's talk about the secrets of the top 1%, the pro moves that take your CI/CD game from just working to world-class. First, they enforce strict quality gates. No exceptions, no, I'll fix it later. If the tests fail, the build fails, period. Second, they design every test for parallel execution right from the start. That means every test is totally independent. Why? Because that's how you go from a 20-minute test run to a 2-minute test run. Speed is everything. And third, they automate everything, especially the boring stuff like generating and publishing test reports. Now, I want to double-click on that first point because it is the most important concept here. A quality gate is your automated checkpoint. It's the bouncer at the door of your production environment.
If bad code shows up, the quality gate says, nope, you're not on the list, and stops it cold. It's your automatic guardian.
Look, if you forget everything else from this explainer, remember this. Your single most important job when you're building a pipeline is to automate that quality gate. That gate is the safety net that gives your entire team the confidence to move fast without constantly worrying about breaking things. So you did it. You've built a smart pipeline. It catches bugs, it keeps your secrets safe, it protects production. But now I have a new question for you. Your pipeline is smart, but is it fast? Because getting feedback in 20 minutes is nice, but getting that same feedback in 2 minutes? That changes everything. And that's exactly where we're going next, mastering parallel execution.